What's up, you guys? Welcome back to the channel. In today's video, I'm going to show you how to create this Ohm's Law electricity solver in Python using the Kivy graphical user interface. We're going to do it totally from scratch. So in the world of physics, there are these four problems, these four variables: power, voltage, current, and resistance, and they all really feed off of each other. Ohm's law is actually the formula at a base level that says V equals IR, or voltage is current times resistance. But since power is voltage times current, or resistance times current squared, or voltage squared divided by resistance, it's pretty natural to group power in with these three. So technically, Ohm's law is V equals IR, but power is a really normal extension off of that. And you can see from this wheel I have on screen right now, you can solve for any variable if you know the other two variables. And so what I thought would be a really neat problem, a really neat Python project, would be create an application like you can see on the screen where you give it any two of these variables, and it can just solve for you for the other two. And we can use this system of basic equations and just create an app that can tell what givens it has been given, and then it'll even show you the formula that it uses to come up with the solution. Because obviously, as some people pointed out on my kinematics video that I made using tkinter, I'll leave a card to it somewhere up here, but the goal is not to decrease the learning of anyone who would need to use this tool. So you would still want to see how you got to that point, so you could always check and verify your math and make sure that, like, if this was something you were using in school, you could still pencil down like what formula got you there. It's just kind of a shortcut, and it's a useful programming exercise. So hopefully you find this useful. Hopefully you think this is kind of a fun, neat project that you'd like to follow along with. If you do want to see something specific in the future, be sure to leave comments on the video. All the people who leave constructive feedback, I really appreciate those guys and gals. Special shout out to a couple accounts that have been leaving like tons of great feedback recently. Dale, Dubper, Empire of Programmers, and Fleo Inc. I'm sorry if I mispronounced any of those names, but these people comment on a ton of my videos. Really great support. And so if you want to see something in particular on a future video, be sure to be like them, subscribe to the channel, leave some likes, leave some comments, and if you really want to support the channel, check out the link to my Patreon in the comments below, in the description of this video. And without any further ado, let's get into the tutorial. All right, let's get right into this. If you have never used a program with Kivy before, I recommend you check out my Kivy intro series playlist. I'll leave a card to that as well, somewhere in the top around now, because I'm not going to go super in depth about every Kivy concept in the video. I'm really going to use them, and I'll talk about them as I use them. But if you want to know some background of why we're doing things certain ways, feel free to check out that playlist. I go much more rudimentary there. So for now, let's just get started building this app. And I'll probably click back to this wheel fairly often, because these are going to give us all the formulas that we use in our decision making. But for setting up the app, we really don't need that yet. To set up the app kind of in Kivy, the way you're always going to want to do this is start by doing some imports if you know generally what your app's going to look like. So you actually don't have to do this like import Kivy that you have to do with almost any module, because the way we're going to do it is from Kivy dot and then we'll do things like app and then dot user interface, things like that. So you don't need to import the whole Kivy module with an import statement. We're going to do it this way. So to start, we're going to import just from Kivy.app import app, and then as we build this app out, we're going to be importing more things like buttons, labels, layouts, text inputs, things like that. But for now, we're just going to start with the app. And we're also going to have some other input statements, like we'll need math and function tools before this is over. But okay, so to get started, we're just going to set up a class for our app, and we're going to call it Ohm's Law App, just like that. And then in parentheses, you tell it what it is, and it's an app. So just like that. And then we're going to give it this line, define, and then build self. And in general, like I said, this is just how you want to have the the app setup. This is pretty generic Kivy. Once you get more familiar with the program, there's definitely different ways you can go about this. But for now, since this is kind of more of a beginner tutorial, just follow along. And if you have any specific questions, let me know in the comments below. But then, so inside build, tell it to return whatever starting screen you want to have. Since we're going to have a single screen application here, we're going to call it the Ohm's Law input screen. But if you wanted a startup menu, this would be a good place to put the menu, and then from the menu it would call the other screens. But so we're going to name our main screen that the whole thing happens on the Ohm's Law input screen. And we need to come up above and just kind of make another class for that. So this class, Ohm's Law input screen, is going to be a new thing we'll have to import because I want it to be a grid layout. And again, I don't want to talk too much about all the different layout options: box layout, grid layout, float layout, anchor layout. There are a lot of different Kivy layouts. I don't really want to go into all of the options in this one. So just so you know, a grid layout in general separates your screen up into rows and columns, and then as you add widgets, it's going to put each widget in the next available space. What I'm going to do is I'm actually going to have an overarching grid layout, and then for some of the widgets in that layout, I'm going to make them additional box layouts. So there's so many different ways you can design in Kivy. This is not like a full-blown course on Kivy. This is how to make a specific app. So let's keep going. But you'll see we need to import this. So if you're using a good IDE, like I use the PyCharm one from JetBrains, when it recognizes there's something that hasn't been imported, it usually can suggest the import statement for you and just tell you. But if you don't have an IDE that can do that, just go up and do from kivy.uix.grid layout with lowercase like that, import, and then grid layout with a capital G and an L. That's called, I believe, camel case or maybe Pascal case. There's all these different ways of naming it. But so first letter caps for grid layout. And now we can define this grid layout in here. And when you're defining a layout, you want to start kind of like a class in Python. Even if you're not doing like a Kivy, you want to start with this def init. And then you pass in self and this star quargs, which is, I believe, keyword arguments. But it's essentially saying pass in any parameters that I give it. And then we're going to call super, which is saying inherit the any properties of a super class that I'm underneath. And for this, it's just the name of the screen. So Ohm's Law input screen like that. And then comma self like that. And then do dot underscore init underscore star quargs. Okay, so I know that if you're not familiar with Kivy and you're not like a super experienced programmer, there's probably a lot in these lines that don't make a ton of intuitive sense, but just follow along for now, and as you become like a better programmer, you'll start picking up what all of these things mean. So for this overarching layout, I'm actually going to make it just one column grid. So it's not exactly a grid. You can think of it more as like one vertical line of widgets, but you'll see why I do that, I think, as we go through the app. And for self.rows, I'm going to start with 10. We might actually need to increase that as we go, but let's just start there. And now I want to come down back where we were building like the code down here below. And I want to just add the last piece to sort of make this thing go. So it'll be if _ name _ equals, and then in quotations _ main _ and then Ohm's Law app dot with parentheses dot run with parentheses. So this is saying if the screen name is main, which by default your first screen that pops up is going to be the main, run the app. So let me see, this might not actually run, but Yeah, there we go. So we haven't put any widgets on the screen, so it's obviously an all black screen, but you could see just with what we have now, we got enough to make the screen pop up. And now we're gonna start actually putting things on the screen. So let's start adding like the labels and the inputs and the text and all the things we want to prompt the user with. Okay, so the first kind of widget we're going to use is going to be a label. So let's start with a title label, and it's going to be title equals and then label with a capital L, and then we're going to give it some information inside of here, like what kind of text it needs to have. But you can see we need to import the name, and we want this to be kivy.uix.label. So it's going to give you just like the grid layout, kivy.uix.label, import label with a capital L. And now we are defining a widget, so we can do a few things. We can start by saying what text we want the label to have. And I want this to say Ohm's Law Solver. Now the apostrophe is a special character inside of strings, so if you want an apostrophe to appear, you need to do this backslash apostrophe like that. And that'll give us Ohm's Law Solver. Okay, and so that's the title we're going to give it. Now there's something else you can do with labels, which is nice, and buttons. You do this font underscore size, and then you give it a size, and I'm going to do 32 SP, and so that's just going to make it a bigger font. You can play around with style all you want. Additionally, you can do color, which if you're familiar with RGB colors, this is a little different. This is like the RGB values divided by 255. So I'm going to do like a gold that I liked during playing around here, but just understand this one is actually saying 255 divided by 255 for RGB. And so this is like 0.8 times 255 divided by 255. So basically we are calculating the decimal equivalence of RGBs out of 255. It's just another form of like playing around with style. All you have to do if you have an RGB color that you like is divide them by 255, put them in here on a scale of 0 to 1, and that's how you get your color. For the label specifically, color changes the text color, not the background. And then another argument we're going to give it right now is just bold equals true. So this makes the text a little bit easier to read. And now what's cool is we've defined the label right here just with this information, but there's a second piece. We have to do self.add_widget and then just give it the name of the widget. So for us, it's going to be title. And now if I boot this thing up, you'll see we get Ohm's Law Solver. It takes the whole screen up because we haven't put anything else on the screen, but you can see it's bold, it's big text, and it's gold. So that looks pretty cool, and we just played around with a lot of parameters on a label widget, and that's actually going to make a lot of our widgets that we're adding here in the future a little bit easier. So let's go ahead and add a second one that we'll call instructions, and I didn't spell it right. There we go, instructions. And let's make the text on this one enter known values and tell them that there's a minimum of 2. So the thing to solve this, to solve these Ohm's Law problems, we need a minimum of 2 knowns, right? So let's go ahead and say font size for this one doesn't need to be as big, but we'll still want it to be kind of larger than the default, which I think is 12. So we'll make this 20. I'm not going to give it a special color. It's going to default to white on a black background, which will look fine for instructions. And I'll leave it bold. I'm pretty much all text I make bold unless it looks weird for some reason because it makes it easier to read. And then let's put that on the screen. Let's do a quick style check, see how it looks. Enter known values, minimum 2. That looks pretty good. So let's keep going. Now the next thing, obviously, we just asked them to enter their known values. So the next thing is we want voltage, current, resistance, and power all to be a label and then a button. And I'm going to show you here why we are going to want to do this as a new class. Because with the grid layout, right now it's just automatically dropping them in the next available spot. So what I want is the next available spot underneath instructions to be a label on the left side and a text input on the right side. So we're going to want to make a new class that's called label and input. And let's go ahead and do that. And you're going to see why this saves us a lot of writing time once we define this thing. So, oops, there we go. So let's go ahead and say class label and input. And I'm going to use that kind of like first letter of every word caps standard that Kivy has because it's already here. And I'm going to make this a box layout. Okay. And we have to import that as always. And let's go ahead and say the same thing because we have a new class here, def init self, and then we're going to pass some things in. We're going to pass the text that the label box should have, so input text. And you can set them up here in the beginning with like an initial type or value, so we'll just say none. And then input color, we'll say input underscore color because I want the different entries to all be different colors. So by default, we'll make them white, and then we'll pass in better colors as we go. So we're going to pass in kwargs as well. You have to do that. So just take my word for it. And then we're doing that same super label and input and self, and then dot underscore underscore init underscore underscore star star kwargs, keyword arguments. So I will say Kivy, of like Pygame, Kinter, and Kivy, which are the 3 GUI packages I use the most with Python, I think Kivy might be the trickiest because it has its own design language, the Kivy design language. You even can design the style in a separate app or a separate file that's a .kv extension, and it's totally written in the Kivy design language. There's just a lot of syntax that you have to get familiar with if you're going to make a program in Kivy, whereas I think Pygame and Kinter kind of lean on the Python inherent like language and style a little bit more. So that's just my side note about Kivy here. Is I do think it's trickier than Kinter and Pygame, but the real value in it is it's cross compatible with everything. So Mac, Windows, Linux, iOS, Android, you can build a Kivy app that runs on all of those natively. So if you're going to make a mobile application in Python, Kivy is like your best option for it. There are some other ones, but in general, I've found Kivy is the most immediately useful for creating mobile apps. So we're going to make, we're going to make some rows and columns defined in this box layout. And the real reason I'm doing one as a grid layout and one as a box layout is I just want to show you 2 different layouts. But these 2 are pretty interchangeable, especially for the purposes we're doing here. But for these, I'm actually going to say 2 columns and 1 row for each of these that we define. And I'm going to say first we want to make a label that I'll say self.label. No, label's stupid. I don't know. Let's call it value. Is going to be equal to a label where we say text equals. And then since this is a class, we're going to have a bunch of these. So we don't want to make this too specific. We're not going to pass in the same text for every label, so we're going to have this read from the variable that we pass in. And then let's say color is going to be equal to input color, so the other variable we pass in. Let's make bold equals true, like that. And then we got to do this self.add widget and then self.value, just like that. Value might not be the most logical name, but I already did it, so let's move on. Self.input is equal to a text input. So this is a new type of widget. Make sure to import it again from kivy.uix.textinput, import text input. And this one's pretty easy. It's by default gonna pretty much look how you want it to look. So we'll say multi-line is equal to false, which just means don't let the text break onto a second line. Keep it to 1 line. This is supposed to be you're entering numbers, so it's not like you need multiple lines anyways. But yeah, that should be all we have to do to define this. Now we just want to do self.add widget for self.input. And what's cool is this little class we just made here, we're about to add 4 label and input combos to our overarching, to our master Ohm's Law input screen. And so even though we didn't just add anything to the screen, it's about to become super easy to make 4 of these things. So let's do voltage first. So self.voltage equals our label and input class, and now we just give it two variable arguments. So if you remember, we said first was going to be text, so that'll be voltage, and then I'll tell it it's V, and the units are volts, like that. And then colon, space, apostrophe, and then let's give it a color. I'm a little too lazy to pick out like super stylish colors, so I'll just make it red. But now the second piece, all we have to do is self.add widget for self.voltage. And what we should get is a label and a text input that tells us about voltage. So let's see. Okay, voltage V volts, and then a spot where I can enter, the voltage. And obviously there's enough space here that I could enter a very large voltage, but typically it's going to be like 0 to 480 at a maximum. So that looks pretty good. We're gonna play around with the style at the end as well, try to make things spaced a little more logically, but for now let's just go ahead and add current, resistance, and power as well. So I'm actually going to define all 4 of them and then add all 4 to the screen. So let's see if I can do that without making a mistake. So we'll do V equals IR, that kind of order. We'll do self.voltage, current, resistance, and then power. And this is going to be current, and then it's going to be, this one is I, and the units on current are amps. And then this one is resistance, and R, and the units on that are ohms. So this is some pretty basic electrical engineering sort of stuff, but I do think that anyone interested in science, computer science, especially programming, where the fields are not that far apart, like knowing some electrical concepts and knowing, some computer science concepts, they go together really well. So it's not a bad idea to be familiar with Ohm's Law, really. So even if you're thinking, well, I like the Python element of this more than the electrical element of it, I think open your mind. This is cool, knowing both. So we're going to do red, and then we're going to do green, and then this is not exactly a bright blue. It's a little bit easier to read. And then for power, we're going to do R and B, which gives us kind of like a pink. Again, if you don't like any of my colors that I use, play around with the style on your own. These are just RGBs, so pick whatever you want. I just kind of try to use some easy numbers, some easy colors, because I want this to be more of a tutorial on the substance of this app. And then obviously if you decide to make this your own, then you should play around with the style, because you want it to look pleasing to you and obviously to users if you plan on sending it out. So then just do self-add widget for all of them, and I believe that should give us these nice 4 rows that each of them is going to say is now associated with a different variable. So later, when we actually do the functionality of solving for the different things, we can just address like the voltage text input box and get the value out of that. So that's really the power of creating this label and input class. Is now we just made 8 widgets just by defining them. All we had to give them was text and a color, and it put a label and a button on, or a label and a text input on for everything. So that's super duper useful. And then I think what we want to have next is a series of buttons that we want to say, like, solve for voltage, solve for current, solve for resistance, solve for power, because obviously you can solve for any of them. And so maybe you've guessed it, but I want this to be 4 buttons all in the same row. And since our overall grid layout is only 1 row wide, we're going to create a new class for our buttons. So to do that, I'm going to call it class button box. And I'm going to make this another box layout. We don't need to throw a third layout in the mix. I'm not going to show you guys like an anchor layout or anything. So we'll do def init, and then self, and then kwargs should be all we need for this one, because we're only going to make one series of buttons, but this would be useful like if you were going to try to combine this and the kinematics project that we already did in Kinter. You might want to use this same button box layout over there, so maybe you would want to pass more variables in that case. But we're going to keep it simple for now. So super button box comma self, and of course by now hopefully you're just used to seeing these things, or you're getting there, but star kwargs. And for this one it's going to be self.calls. We're going to make it 4 columns wide, but then only 1 row, so self.rows equals 1. And then I'm going to make 4 buttons real quick, so I'm going to say self.solve for v is equal to button with capital B, the text equal to solve v, so solve for voltage. And then let's make the colors the same as what we just defined them in the labels, so 1 0 0, and let's make it bold. Bold equals true. And let's take this same oh, this is our first button. Cool. So we have to import this. I was like, that's weird, it's not working. So we need Kivy.uix.button with lowercase b, and then import button, capital B. Okay, I was like, that's weird. We've definitely used buttons, but no, we haven't. All right, so we're going to do this 4 times again. So V, I, R, P, solve for V, solve for I, solve for R, solve for P, just like that. And then let's update the colors. We had R, then we had G, and then we had this kind of easy to read blue, which is all the B, 1 B with half G, and P is this kind of like pinkish color. Okay, but then we're going to do self.add widget, and we're going to add all of these. So self.solve V, and I'm going to copy that 4 times. And so basically what you're seeing hopefully is that complicated app layout is really just you want to break it down into simple subclasses. So like if you run this now, so we are going to go up into our master screen and just do self.add widget, and we're going to add a button box. So self.buttons is going to be equal to button box, just like this, and then self.add widget buttons. Oops, self.buttons. Self.buttons. Even after you've made a lot of programs, you'll forget things, silly little syntax things. So what you should see now is, okay, so we've got these 4 buttons going across the bottom of the screen to solve the 4 variables, and they don't do anything right now because we haven't written the code for them to do anything. But actually, if you're looking at this app, you have to remember that the overarching like grid layout is only 1 column wide. So each row is considered 1 widget to the overall app, but you have the ability to take another layout and stick it inside of 1 widget. So these 4 buttons are technically 1 widget, and that's the buttons box. But inside of buttons box, we put 4 widgets in there. We put 4 separate buttons. And you could even do like all 8 of these, all 4 of these labels and all 4 of these text inputs inside 1 widget. And so then you could do like a 2-row, 2-column layout, or a 4-row, 2-column layout all within 1 widget. And so you make these complicated apps that really just break down to a series of more simple applications. It's almost like if you're familiar with like advanced calculus, there's this thing, a Laplace transform. You take a very complicated math problem, solve a comparable, simpler math problem, and it translates into something that actually gets you pretty close on the complicated version. So I like to think of this almost as like a Laplace transform of complicated apps. If you thought that was stupid, I don't care. Leave me alone. Okay, now let's just put the last two labels that we want to show on the screen, and then we'll start doing the button functionality, because that's the actual programming part of this. The rest of it is just kind of learning Kivy. Okay, but so then what we want to do is we want to make a couple labels. So we'll say self.answer is going to be equal to a label that just has the text of answer in the beginning, and we're going to update what that text says when we actually solve the problem, but just to load it in initially, we'll have self.answer, and then we're going to show the formula. So if you did watch that kinematics one, you know, I think it's useful to show the actual work, because we want to, like, say you were using this to shortcut your homework, you're still going to be required to show your work more likely than not, and it's useful at any time to be able to see how you're getting an answer, purely just to verify that you're getting the right answer. So we're going to show the formula that we use to get the answer, and that'll be kind of an easy addition to the project. But so then let's add both these widgets, self.answer and self.addWidget self.formula. Okay, so let's load this up for like a final style check. All right, I think this is going to look pretty good now. So I think we'll put in our knowns, a minimum of 2, and then we're going to write the programming such that when you click these 4 buttons, they're going to go to the solve function that we're about to make, take the known values, and try to produce the correct solution. We'll then put the solution here, and we'll put the work that we use to get it here. So another nice thing about Kivy in general is it is natively resizable. So that again helps with the cross compatibility of it. You can change style a little bit, and we probably will, but by default every widget is going to have the same height, and then every widget is going to have the same width by default. So like we made these 4 buttons and we didn't change any of their default sizing, and so they all have 1/4 of the width. Same with this label and this text box. We will talk about size hints after we make the functionality, because I think you've come a half hour into a tutorial. Let's actually get into making these buttons do something. So now when you want to use a formula for Kivy where you pass in parameters, you need to have a function tool that's called partial. And this is kind of comparable to, like, if you're familiar with the Kinter using like lambda when you push a button, we're going to do the same kind of thing. So we'll come down below where we throw the buttons on. So here we have self.buttons equals buttons box. And we want to make it to where self.buttons.solve_v, so let's start there. And then to bind the press of a button to a command, you do this self.v or self.buttons.solve_v.bind. So the name of your button and then .bind, and then you have a few options. You have like on press, on release, a few others. You can look up the Kivy text online. But we're going to create a formula that's like self.solve, but then we need to pass in what we're solving for. And you can't do it the normal way where you just put these parentheses here and then you say what you're solving for. That doesn't work with Kivy's style. So what you have to do is you have to do on press equals and then this partial and partial. There you go. And we do self.solve and then comma, and then the parameter you want pass in, and then close parentheses. And so to use this partial, you need to import from a module called functools.partial. So function tools import partial, just like that. And now what's nice is we can create this formula, self.solve, for all 4 of our buttons, V, I, and R, and P. And all we have to do is just pass in what we're solving for. So then we'll do all the rest of the work inside of the self.solve function. So, you know, I think that's pretty useful right there. You just have to know this little bit about partial. I think there's a comparable way to use lambda as well, but we're going to go with partial because that's how I learned it. And I think that's pretty easy, to be honest. So, all right, so underneath where we're adding all these widgets, whoops, but still inside of the Ohm's Law input screen, we want to come down and we want to add another function. So define, and we called it solve. So self is always going to get passed in. We'll call target, like what we're solving for is the target. And then when you're doing something that is a button, like formula, so you're solving for a button, you want to put just button in at the end. It's going to throw an error and say you didn't pass in the right number of arguments if you don't have this button here. So just, I guess, take my word for it on that one if you haven't used it, or you can try deleting button out and see what happens. So we're going to start with this values list that I'm going to have as all zeros. And then we're going to start solving for the different variables. So first I'm going to say if self.voltage.input.text is not equal to, and then empty string. Okay, so this is saying if you entered something in voltage, colon, then we're going to say values 0. So voltage is going to be value 0. Is going to be equal to, and I'm going to convert all these strings into floats now. So I'm assuming you entered numbers because you want to solve for a numerical thing, is self.voltage.input.text. So this is how you get the text that was entered inside of that text input. If you remember, inside the text input, like the label and input, we called that whole thing self.voltage. So we go to self.voltage, and then we look at the label and input, and it's the text input, which we called input. So what we're saying is self.voltage, which is a label and a text input, and then .input, which specifically was the text input, and then .text, which is whatever we typed into it. So we're checking to see that something was entered in there. We're going to convert it to a what am I trying to say? We're going to convert it to a float in here so that we can do math with it. And we're going to do that same thing 4 times. So do a little copy paste and try to go through quickly here. Again, I know I'm trying to cover a lot, and I'm trying to not make the video too long. So if you have questions about anything specific, the best way to get them answered is just ask them in the comments. A lot of the people who watch these videos are smarter than me, and so someone other than me might even get you an answer before I do, but I do try to check those fairly often. So self.current.input.text, self.resistance.input.text, self.power.input.text. Okay, so we're going to get those 4, and this is just basically updating this initial list of zeros that we made in the very beginning. And then I'm just going to do this next step. You don't need to, but it's going to make the rest of all the formula checking a lot easier, I think. I'm going to move all of the values we just calculated into these little variables that I'm just using in this solve function so that I can create some very simple formulas using V, I, R, and P, which is kind of what I'm used to. Okay, so now we're going to start actually using all of these formulas, all of the V, I, R, and P formulas based on what our target is. And let's start with voltage. So I'm going to say if target equals V, which is saying you clicked the button to solve for voltage. Well, first thing, and probably the easiest thing, is if V is now not equal to 0, then we're just going to, so we're going to do 2 things for every scenario. We're going to say what formula we used and put that in like the formula work variable. And then we're also going to say what V should equal. And the thing is, if V does not equal 0 and you wanted to solve for voltage, that means you entered something in the voltage box and then clicked solve for V. So we're going to assume that you accidentally clicked this, and just for work, we're going to say V is equal to V. And then we don't have to set V equal to anything new because I guess it doesn't like that style, because you've already solved for it. But now the next scenario, let's start looking at other combinations of variables. So we'll say, all right, so you didn't enter something in V. So that's what the elif means. It means else if. So V does equal 0, but I doesn't equal 0. And then there's 2 scenarios here. There's you're trying to solve for V, and you know I. Well, now we need to know whether you know R or P. So we'll check R first, and we'll say if r does not equal 0. So now we're saying you've entered I and r. We want to solve for v. This is great. We say v equals I times r. And then the work is really easy. So the I times r, like that. And then we set this work variable, that's just a string showing what formula we used, equal to I times r. So in general, you're going to see this. You're just going to see me saying the actual math that we're doing to solve for v. And then you're going to see the exact same formula used just for the work. All right. Now, we're saying L if I does not equal 0 and R does not equal 0. Well, the contrary to that would be, I and P instead of I and R. So if P does not equal 0, now we're saying I and P and you want to solve for V. So you can come back to this circle if you want. We're solving for V. We know I and P, so it's just P divided by I. So V is equal to I divided by P. And the work for that one is, hopefully you're picking this up, V equals I divided by P. And I know some people said on the kinematics project that like my math got a little confusing, but really it's just checking what variables were entered to make simple decisions about which simple formula to use. So if this wheel makes sense to you, then the programming should make sense as well. I am trying to explain my thought process, but there's kind of no super easy way to get all these formulas written down without going a little bit quickly, because it would be a really long video if I just showed 20 different formulas and how I got there. So now the last scenario where we actually got valid inputs, which means at least two knowns, would be we have P and R. And so in that case, V is going to equal math.square root. And so this is something new we have to import because we weren't using the math module yet. So make sure you import math just so that we can use this square root, because if we know P and R and we're solving for V, it's the square root of P times R. So you just do P times R. And then for the work for this one, since it's not super easy to type the symbol for square root, I'm just going to say the work is equal to, and then just SQRT like that, and hope that they know that means square root. And then P times R. So like that. And now the last, we do need one more else, because else would be you didn't enter two valid inputs. So like if you just entered I or you just entered P, we still want to say like invalid inputs like that. Okay. And then we're going to make this new variable so that there's actually some text, and we will say answer is equal to a string. And I'm making a formatted string so we can use V, and I'm going to say voltage is, and then colon, and then curly brackets, string conversion now of V, because V is a numerical value. And I guess actually it doesn't need to be a string if we do formatted. Silly. But we can round it, because if you divide to like 12 decimal places, that's not really useful. In general, I'd say like 3 or 4 is plenty. You can play around with that if you want more or less. But, whoops. And then I meant for volts to be outside of the curly brackets. So like this. So basically, we're going to come down after we check for the 4 targets, and we're going to say at the very bottom, outside of all of our if statements, but still inside the solve function, we're going to set 2 things. We're going to set self.answer.text equal to the answer, which is this string. Voltage is, V volts. And then self.formula.text is going to be equal to the work variable that we come up with. So now this would work, and it should work if we solve for voltage. So let's go ahead and just test that to see kind of a sanity check here. Let's say we have 2 amps and 2 ohms. And if you know V equals IR, if I click V, it should tell us that there's 4 volts, and the formula should say V equals IR, which is sweet. It works. That's great. But this is only going to work for volts. So now I'll try putting 2 in power instead and solve for V. And we get V equals I over P, which is cool. And now let's see There you go. So if we have v equals square root of p times r, it still solves for v. So this is awesome. We're 1/4 of the way there. If you want, if you see where this is going, you can just take this wheel and apply the same kind of thing to the solve functionality if you don't like following along with me. But if you're enjoying it, let's go ahead and do I, R, and P together here. So we just did V. Now we're going to say elif target is equal to I. And since hopefully you understand where that whole first series came from, we're going to go pretty quick making this apply to the other ones. So now it's going to say if I does not equal 0, that means you entered something for I. And so now I'm going to just swap kind of I with V here, I think. And so we'll say if you know V and R and you're solving for I equals V divided by R. And then the work is just obviously going to say I equals V divided by R. Then the next one will be, you know, V and P now. And so that means I is equal to P divided by V. And the work is just going to be I equals P divided by V. If you don't know where any of the formulas are coming from, take a screenshot of this, look up the Ohm's law power wheel on Google Images. It'll show you this exact image. This is where all the formulas are coming from, and I don't want to click back to it every single iteration of it because this would be a very, very long video. So now let's say you know P and R, but you don't know I, so you're solving for I. That formula is I equals the square root. So again, we need the math.sqrt, and then this time it's just the square root of P divided by R. So like that. And so the work for that is going to be I equals the square root of P and then divided by R. Alrighty, so let's go ahead and let it auto reformat. So now that should work for everything for I. I'm going to go ahead and copy the V and I stuff. And we are gonna oh crud, did I not copy the else statement? Oh, Pete, silly goose. There we go. Else invalid inputs, and then answer instead here should be current is round I amps. Okay, and so I think I goofed that up down here as well. So we're gonna just need to remember else I is equal to invalid inputs. Yeah, all right, we're okay. This will be an easy fix. But if target equals R now, if R does not equal 0, then work is going to be R.R. At the end, I want to remember to change this to resistance, and we'll go back and fix the formulas in just a second. The units on resistance are ohms, and then this one will be target P. So if P does not equal 0, we just say P is equal to P. What's wrong with you? You should know that. And then we'll copy this last little block here, this else statement that I cut. And else P is equal to invalid inputs. The answer will always be power is P watts. All right, now we can fix the formulas for R and P. So let's say to start in R, let's say you don't have, or you're given I and V as the first scenario. So I and V, that means that R, you think back to V equals IR. That means R is equal to V divided by I. Make the work R equals V divided by I. And then otherwise, you know I and P. Well, that means that R is equal to P divided by I squared. And to raise something to a power in Python, it's 2 stars, if you don't know that. But R equals P divided by, I think the little caret for the work will actually make it clearer, because this is a little more universal, the sign for raising something to a power. All right. So that's work equals P divided by I squared. And then the next scenario is going to be for solving for R that we know P and V. That's the only one we haven't done so far. And this means that R is going to be equal to V squared divided by P. And make the work R equals V caret 2 divided by P, just like that. and then otherwise it means we haven't gotten 2 inputs and we weren't given R directly. So we will keep that. And now we are on to the last bit of formula solving. So we'll say target equals P. Obviously P, we already did that bit. Now let's say we're given V and R. The formula for P is V squared divided by R. So then the work for that becomes P equals V caret 2, because I decided that looks better. If you don't like it, do whatever you want. Okay, and then the next we'll say V and then I. And so if we have V and I and we're solving for P, that formula is just P equals V times I, which is pretty easy if you know like volts times amps is watts. If you really dive down into your units, that's kind of the same thing. So hopefully that one makes sense to you. Now if the last scenario here is going to be R and I. So if I and R, and we're solving for P, and the formula there is P equals I squared times R. Okay, so P equals I squared times R, just like that. And now this formula, which I know it kind of looks like we did the same thing 4 times, but there really wouldn't be a good way to put that in a function or like a class, because the formulas are all slightly different. So I think this is really actually a pretty intuitive way to do it. I'm going to change that to an elif. And why doesn't it like it? Elif target. Oh yeah, this whole thing is one indentation too far in, isn't it? How's that? Elif, if, elif. I'm trying to figure out why it's unhappy. Elif. And is it you? You're too far in as well? Like that. Yeah, that should work. So I think to test this, the best way would be go online and look up some Ohm's law practice problems. But I'm going to just open it up with you real quick, test a few, make sure every button is working. So let's put 2 and 2 in there, solve for V. So V equals IR, P equals I squared times R. That looks pretty groovy. I'm going to put a 6 in here, solve for V, square root of P times R, square root of P divided by R. So you can see it's giving us each answer. It's giving us the formula of how we got there. And if we were to click on one that we put in as a known, it's going to give us just like, hey, you told us that already. So, you know, I think this looks really good. I definitely recommend, if you're making it on your own, look up some practice problems, compare your answers versus the ones online. I don't want this video to get too long, and we do still want to talk about style, because I know I mentioned discussing size hints a little bit earlier. So let's get into that now. So I'm going to come down and start in my label and input box layout, because this is a pretty easy place to talk about it. So we have these labels and these text inputs, and I actually think the labels don't need to be half the size of the screen. So like by default, you know, they're going to get half of the width available to them. Well, we can step that down a little bit by saying 0.4, and then 1 is saying take the full Y available to you, which is fine. And then we want to take this size hint, because all it's saying is I want you to still be resizable, but I want you to kind of change what percentage of your available space you're using. And so we'll say 0.4, and then for the actual input box, we'll say 0.6. And let's see what doing just that does. So now hopefully you can see this line was originally down the middle, kind of between where these buttons were, and now it's shifted over here because we've said, well, we only want the label to take up 40% of the screen. So that's a pretty easy way to resize it. One more thing I think we should do, because what we did there is we resized some X parameters. I think we should take the text, like the labels, and I think we should make them all only half the height available, because obviously the buttons and the like text input are a little bit more important than just our regular text. So I'll come into the main class here, and all the places where we have a label, so like the Ohm's law solver, I'll say, well, use your full X span available. I want you to span the whole screen, but I only want it to be half as tall as like the buttons and text input stuff. So realize what you're doing with size hints is you're resizing stuff relative to other stuff on the screen. This is part of why Kivy's like automatically resizable defaults are so useful. It'll always fill the screen. You're just giving some size hints so that stuff you want to be a little bigger and a little smaller, resize. So there, I made all 4 of the labels take up half of the vertical height that that the like buttons and main input areas take up. So hopefully that looks pretty good to you. I still think it's super easy to use. It's very readable. You know, you could make the font sizes bigger. I think hopefully in this video, and if you're familiar with Kivy in general, you know how to take the style and make it your own. I hope you've kind of enjoyed seeing the functionality that we put into this. In general, I think cross-disciplinary apps are really where like programming engineers who also have a fundamental understanding of other engineering concepts can really find a lot of value, because you're creating easy to use programs that other people will actually be able to use for real concepts, engineering concepts. So hope you found this video useful and enjoyable. And as always, if you have any questions, comments, or want to see something specific in the future, let me know about in the comments below. I really appreciate the feedback. If you want to become a super supporter of the channel, I really appreciate anyone who wants to check out the Patreon. All tiers are super appreciated. I'm still fairly new to the YouTube game, trying to figure out how to make the Patreon worth it to anyone who wants to subscribe over there. So if you have ideas about that as well, let me know in the comments below. Make sure you're subscribed to the channel. Leave a like on the video. If you watched all the way through to here, you're my hero. And I just really appreciate everyone who's supporting it. As always, good luck with your projects, and thanks for watching. Thanks. Bye.